All right, everyone. So let's start. Seems like everyone is busy doing their breakfast. Okay, are my slides visible?
Yes, ma'am.
Okay. Okay. Can you see my whole screen or just the slides? Can you tell me?
The whole screen, ma'am.
All right. All right. Okay. So this is the agenda of today's session, as you can see. So what we'll do in each session, we'll divide the session in three or four parts and we'll talk about three or four key ideas in each session so that we remain organized. So these are the four topics which I would like to discuss today. So the first one is the use of graph theory in social computing. So as I told you, social computing, it's a highly interdisciplinary field and it borrows ideas from a lot of science subjects as well as computer science subjects, but today we'll talk specifically about the role of graph theory, and later, as you see, we'll see the importance of other areas like graph theory, random walks, Markov chains, economics, sociology also. So coming to the graph theory, a graph theory is not a very stringent prerequisite for this course, but it will really be nice if you remember something from graph theory, or if you remember some ideas from there. So let me just unshare the screen for a while, and can you all come forward and tell me what all do you remember from graph theory? Anything which you remember from the course. You can talk about what the course was about or some specific topics in the course or one idea which you liked in the course. Anything. Would anyone want to go ahead? Okay, can someone tell me what a graph is? I expect the answer from at least third year students. I have taught you the topic. All right. No answers. All right. So we'll revise some topics if required. So that's the first idea. Then we'll look at some of the interesting graphs. And when I say some interesting graphs, I'm again not talking about the kind of graphs you have seen in graph theory. So again, I would like to pose a question. Do you remember some of the graphs which you have studied in graph theory, some specific kind of graphs? You would have studied about linked list, right? That's also a kind of a graph, a linear graph. You do you know about trees? Can someone tell me what a tree is?
Is it a graph with no cycle?
It's a graph with no cycles and it should be connected. Exactly. Right. So these are the kind of graphs which you see in graph theory, but in this course we'll talk about some more interesting graphs and which are more application oriented in a particular context. So if you look at graph theory, it's a very theoretical subject. Now we'll look at some of the applications of the subject. And in as our third point, we are going to have an interesting classroom activity. This will also form your first assignment. Right, and as I told you, each of your assignment is graded. So how much you participate in these activities, those grades will disperse to your assignments also. And if we have some time remaining, then we'll talk about some prospective project ideas. So while I go through the first 3 points, there also you'll see some project idea. We'll specifically have a session or and we'll devote some time to discuss some project ideas. So you can always come up with your project ideas or you can pick one of these if you are unable to find an idea on your own. All right, so let's start this session with this puzzle here. So it's less of a puzzle but more of a thinking exercise, requires you to be creative. So as you see here, there are two pictures on this slide, one on the left and other on the right. Can you enlist all the differences between these two pictures? Any difference which comes to your mind? I'll give you some time to think.
First one is more organized than second one.
Okay, that's like one of the most frequent answer which I get. Very good. So the first one is more organized, second one is more chaotic. All right, anything else? So give me at least some 10 differences. Now Didi is the only one speaking. I expect others also to come forward and it can be any difference, whatever comes to your mind.
Ma'am, the left are kids and the right are adults.
That's another good difference. Right. So you can see the age group in the left hand side, these are some kids. Right hand side, it's all the age groups. And mostly you don't see a kid on the right hand side. Okay.
So yeah, one is a school and the other is probably a theater.
Yes, the location. So the first one is a school. These are the kids studying in the school, and in the second one, it's a theater. People who are waiting outside. So I asked this question to one of my friend, and she said that people on the right they are waiting to go inside, and people on the left are waiting to come outside. And it generally happens in a classroom. Okay, anything else? All right. Can you see any graph theory based difference in these two figures? Might be a little bit difficult to think about it. So let me help you. So if you remember, what is a graph? Can you tell me what are the two elements in a graph?
There are nodes and they are connected to each other.
Yes, right. There are nodes and there are some links between those nodes. I was just scared not to hear the answer x-axis and y-axis. So here the graphs which we are talking about are not those graphs which you plot on xy coordinate system, but rather we are talking about the data structure graph. I hope all of you remember the data structure. So you have certain nodes which are connected with each other. All right. Now, let's say these people on the right hand side, I portray every person. So I take a piece of paper and I draw some circles there. One circle for each person. So every circle is representing a person, right? How do you think should I portray the edges there? In the right hand side figure. How will the edges look like? Will you see a lot of edges? Will you see less edges? Uh, what do you think? See, these are people who have come to watch a movie. Right? Essentially, they will not know each other, so you will not see a lot of edges. And now, definitely, no, there are a very few people who would come alone to watch a movie. So probably they are coming in small clusters of 3 or 4. Right? So if you visualize this entire graph, it will be some circles here and there. with at some places you might see a diode, at some places you might see a triangle. So let me see if I can just draw it on a piece of paper and show you how it will look like. You can also try it. So you can draw it on a piece of paper and put it in the chat window. Let me see if I can share my other screen. Yep. All right, can you see this whiteboard now?
Yes, ma'am, we can.
All right. So what we are doing is each of these people who are waiting outside a theater, I'm representing them as a node here. So I'm having a whole lot of circles. And if there is a connection between two people, they are linked in some way. So they can be friends, they can be spouse, they can be siblings or parent-daughter relationship, whatever, right? So how will these connections look like? So probably there will be a few people who would have come to watch the movie alone. Then there will be certain connections here. Maybe people are in a group of two, and then there might be one or two people who are in a group of three. So mostly what you will see are some, so see these people who have come in groups. So most of the times all of them will know each other because they might be a friendship group in a student, or it can be a family, right? So you will see all these complete graphs lying here and there in this entire network. So this will be the configuration. Now let's talk about the image on the left hand side. How do you think will the graph look there? So again, every kid is a node here in this graph. How do you think will the connections between them be? Any ideas?
Ma'am, can we connect the students who are in same row?
Okay, right. So we can connect the students who are in the same row. So I'm sorry. So in that case, you will see a network which will look something like this, right? So again, something, an organized network as you see in graph theory. But the question here is more about, so see, what is the basis on which we are making these links? We are making these links basis on the based on who knows each other, right? So as you rightly said, it's very much possible that students who are sitting in the same row, they know each other, right? But don't you think there can be inter-row connections?
Yeah, then it can be like a complete graph, like each student know each other student.
Good point. So, Sakshi says it can be a complete graph. So, let's say I have how much is your class strength? It's something around 80, I think, for third years, right? So, what do you think? Can it be a complete graph? So, can I say, so see, that picture is also of a typical classroom. Here I am talking about your classroom. So, what do you think? In your classroom, is it a complete graph? So, complete graph means everyone is a friend with everyone. Everyone knows everyone. Is that the case?
No, ma'am, I don't think so.
No, right? So there are some edges, there are not some edges, and so what I want here is I want a network which sort of looks like the network of a classroom. Right? I can decide to put the edges in many ways here. So I can connect these edges in this way. I can make a big path here, right? But again, it is a network, but definitely it does not represent the friendship links between students. It's not a path, right? I cannot make it a complete graph because everyone is not a friend with everyone. So how exactly can I put these relationships here so that it actually looks like the friendship network of a class? So we will talk about that in the course. I'll also show you a friendship network in some time. Okay, let's move forward. Let me, so few more questions. All right. Another puzzle here. Let's say So till now we have talked about these two situations, and we have seen that we can model these situations with the help of a graph. There are many ways you can model these, right? But right now we are focusing more on the graph theory aspects. Okay, keeping that in mind, here is a puzzle for you. So let's say this is a time when you were in your 5th standard and you were sitting in this let's say boring English class, if English sounds boring to you, otherwise you can imagine some other subject, and suddenly your entire school is set on fire, right? And then all of you are evacuated safely. Now you, your teachers, your principal, you are standing outside your school is still burning, and you have to curb that fire. Now, maybe being a student, you don't want to do that, but let's assume you are the principal of the school and you have to devise a mechanism so that you can curb this fire as quickly as possible. Somehow it's a village and there are no telephonic connections around, so you cannot call a fire brigade assuming you don't have any Wi-Fi connection. It's a very conventional setting, but there is this well which is like 500 meters away from the school, and you have an ample number of buckets. So the question is, what is the best way in which you can curb this fire? Now one way is, so let's assume that you have an infinite number of buckets. One option here is you give one bucket to everyone. Everyone goes to the well, fetches some water and pour it on the fire. But is that the best way, or is there a better way than that, is the question. So as computer scientists, can you think of a better algorithm? So let me put it like this. So let me make the question more formal. Your objective is, first of all, the process should be quick, right? You have to curb the fire as quickly as possible. Second, people shouldn't be fatigued, right? So if they are running with their own buckets here and there is a lot of chaos in the system. They will get tired very easily, right? And they might collide with each other and fall, right? Because everyone is just running around. So can you think of a better way to do this?
So ma'am, one thing I have observed in construction sites, so the laborers, they don't usually like walk around. They walk in chain, like they pass the stuff from one to another, and like that, I guess water can be transferred.
Very nice, right? So that is the answer. So even I have seen that in construction sites, you might have seen workers passing bricks to each other generally, if not water, right? So that can be done, right? So you can make a chain from the school till the well, and you can just transfer buckets from one person to another. There will be no chaos, people will not be tired, and the process will also be quick. So in that sense, see, previously it was an unconnected group. Everyone was trying to do the things on their own. But now people, they have connected with each other in the form of a chain in this case. So if you look at it, you can look at this like little organisms which are connected with each other to make a mega organism. And now this mega organism, it can do something which all these people together, they were not able to do, right? So these were just some nodes, and as soon as you put some links between these nodes, this entire big thing becomes functional. It can do something which this crowd was not able to do. So I would say this is a crowd on the left hand side, on the right hand side, this is a network, and network can do something which crowd cannot do. Now, if you look at this network, it was actually used in the old times when there was no fire brigades, and it was called a bucket brigade network. This network here, which you see on the left hand side, it has some 100 nodes and it has 99 links. So we again take these 100 nodes and 99 links, and instead of putting the links like here you see in a chain, we put it like you see in the right hand side, right? So again these are the nodes. What all we have changed is just the connections, and we get an entirely different network. Now the question is, of what use is a network like this? You already see the answer on the slide. So this network was also used in the previous times, and it was called a telephone tree network. It was used to pass an information quickly. So again, back when there were not telephones, there were no internet services, and let's say there was an important news, a school was shutting down or a hospital was opening up and you had to tell everyone. So this was the method which was used. There would be a person in center who would give the information to three other people, who will give the information to three other people, and the information would readily spread in the entire network. Now the same could also hold for diseases, right? That's why diseases like COVID and Omicron, they are spreading exponentially. One person gives it to three, then they in turn will give it to nine. So it is always increasing exponentially. So 10 to hundreds to uh, so 10 to 100, 10 to the power 2 to 10 to the power 4 to 10 to the power 8, so on and so forth. Right.
Ma'am, I don't think you're sharing your screen.
Oh, is it? I'm sorry, I'm very sorry. Okay. Thanks for telling me. All right. So this network on the right hand side is the one which is a telephone tree network I was talking about. And on the left you have this bucket brigade network. Any queries? Does anyone want me to repeat something? So let's move on. Yes. So the idea here is you see these are the nodes and you change the connections and the picture entirely changes. So it's just an analogy for that. So networks, they are like these two allotropes of carbon. Can you name them? Someone who likes chemistry.
Diamond and graphite.
Yes, right, diamond and graphite. So if you look at diamond, it is hard and crystal clear. If you look at graphite, it is soft and dark. But again, both of them are made up of carbon atoms. In that case, carbon atoms are the nodes, and the entire difference is in how these atoms are connected to each other, how these links are laid between these carbon atoms, and the elements change entirely. So it's just another analogy, more fun analogy, which I have kept for the slide. So all of you would have watched this movie, I'm quite sure. And if you look at this movie, you would, so these are three snapshots which I took from the movie. And you see here also you can see a network component in this. So all these three, what I call it a mega robot, they can perform different functions, and the only difference between them is how the smaller entities, they are connected with each other. If you can look at military squads, so in military squads everyone is connected to everyone else, and this gives an entirely different property to this network, and that property is so strong that these people can even lay their lives for each other. So you change the connections and the things change completely. So these networks which I have shown you till now, they are more like synthetic networks. People are making them on purpose. So in bucket brigade, we are intentionally creating a bucket brigade. We are intentionally creating a telephone tree. But since the course is more about social computing, we will talk more about those networks which are not made intentionally. Something like a Facebook network. Is someone controlling how a Facebook network should look like? So Facebook network again is a graph where you have people as nodes, and if two people are friends on Facebook, you will connect them with each other. So there will be an edge, there will be a link between them. Facebook has a network, Twitter is a network. There is no one who is controlling these networks. Forget about Facebook and Twitter. Think about the friendship network of your class. How students are friends with each other. If you put that on a piece of paper, then what do you think? Are people making that network intentionally? No, right? There are certain things going just beneath, and they are deciding how the network should look like. So this is something how a real world network might look like, and on an outset it looks like very random. It seems like there are no organizing principles behind this network. One astonishing thing about this network is, if you look at the network of human beings, social networks from ancient times when people used to live in African suburbs Two, if you take a snapshot of Facebook today, which you see on the left hand side, the networks are similar. So even if even though technology has advanced, even though we have become more developed, we have better amenities, but the way we connect with each other, the way we make friendships, they are all the same. Now I'll take a quick turn. So this network which you see here, how can I get rid of this? Can I move it somewhere? Okay. So this network which you see here, it is mostly between human beings. And in social computing, we will mostly talk, as the course proceeds, we will mostly talk about the network between people. But you can apply the same principles of network between people to the network between various different things. And what are those various different things? I would like to show that to you. Just a second. Yeah. So here is a small guessing activity. Can you take a look at this graph and tell me what it is all about? Just a random guess. So in this graph, food, right? Your notes are food items, and we are connecting to food items here if they can be used as substitute for each other while preparing a dish. So as you see here, so you have cranberry and it is connected to pineapple, it is connected to apple. It says that if you have to use cranberry in a dish and you don't have cranberry, you can use pineapple, you can use apple. So this one here, it's an ingredients network, and people have actually worked on it, and it would be really nice to put such a network in your kitchen. So next time when you don't have an ingredient, you can use a substitute for this. And this kind of research, it was done at I think University of Michigan by one of the leading network researchers. Okay, here is another network. It's also a food network. It is actually a cocktail network, and it shows you how various drinks are connected. When you make cocktails, what all is required, right? And as you see, the nodes here, which are bigger, they are like the important nodes in this network, some things which are used very frequently in the cocktails. Okay, let me show you some more networks. So this network which you see here, it is from one of my work which I am doing with a private university in South Africa, in South India, and we collected this, we made this network between the students of a classroom, right? So we asked students whom they were friends with. So just a little while back, we were talking about how this network between students will look like. And it looks something like this, which you see on your screen. And as you see in this network, you see students, they make communities. So there are this bunch of students here who talk more with each other. They talk less with others. And you will see such kind of communities in almost every network. The network which you see on the right hand side, it mostly shows you which students are the most connected ones in a class. So the more connected you are, more influential you will be. So if I have to spread an information in your class, I will take these most influential students and I'll just tell them this information, and further I'll ask them not to share it with anyone else. So it will really spread very fast. So this is the network on the right hand side which shows you that, and again you can see that these most influential people, they mostly come from these two communities. Not all the people in this light blue and pink communities, not all these people are influential, but influential people come from these two communities. So we'll talk more about it as we proceed in the course. There are these other networks. These are the course-wise networks. So this time we do not ask students whom you are friends with. We ask them, okay, if you have a doubt in some course, I'll give you a particular course, let's say data structures, and if you have a doubt, whom will you approach? And it's not necessary that they'll approach one of their friends. They might approach a person who is good in that subject. So this figure shows that network, and you can clearly see that there are nodes which are hubs here. There are these particular students which everyone approaches when they have a doubt. So this is another kind of network people have looked into. Look at this. This is another very interesting network. Uh, so this network, it is called synonymy network. Can you guess what it is by the name itself? I'll repeat, it is a synonymy network. So it is a network between the English words based on whether they are synonyms or not. Right? So if I can read something here, so see, great is connected to large. So in some sense, great is a synonym with large, and then loose is connected with light, make, uh, so on and so forth, right? So these are the words which are synonyms with each other, and again these networks, they are highly used in natural language processing. If you are searching if you are writing some keyword in some search engine, right, then you would also like to check with its synonyms. And mostly if let's say a word A, it is synonym with a word B, and word B is a synonym with word C. What do you think? Will word A and word C be synonyms? Is there a transitivity here? What do you think? So let's say A is synonym with B, A is synonymous with B is synonymous with C. Is A synonymous with C?
Not necessarily, I think.
Not necessarily, right? But there are some chances, depends on how these words are used, right? So in that sense, there is this another interesting piece of work which they show, and like Aditi says, it's not necessarily true, right? So look at this, what these people have done, they have taken some antonyms instead of synonyms. So they say, okay, I'm taking beautiful and ugly, beauty and ugliness, and you see there is a long path between them in the synonymy network. So this word and this word mean the same, this word and this word mean the same, this word and this word mean the same. Somehow you can also connect antonyms, probably they should mean the same. So it's how English language is designed, right? So some things can be very context specific, they may change their meaning based on the context. That is what it shows. So there is a path between good and evil, there is a path between hope and doubt, a path between liberal and conservative, and a path here really means that it mostly looks like it's a transitive relation. So let's say happiness and joy, joy and pleasure, right? If happiness is a synonym with joy, joy is a synonym with pleasure, then probably happiness is a synonym with pleasure, right? But again, things change based on context in the language, and hence even if you take it many steps further, even antonyms are connected with each other. Okay. So again, as I'm discussing about these networks with you, what I am trying to show you here are the diverse contexts in which this network theory has been applied. And just a second. And you can pick some of the project ideas from here. So the idea is to think about a relatively far away domain about which no one has thought of in network terminology, and then try to see, can you model that as a network and figure out something interesting from there. In that sense, I am now giving you a YouTube video to watch, and it shows one of the very interesting network which was constructed about 2 years from now. It's a relatively recent research, and this research, it was published in one of the in the topmost journal, which is Nature. So I'm giving you the link in the chat window. Watch this video. I'm quite sure that you'll find it interesting. Once you have watched this video, just type a +1 in the chat window so that I can proceed further. Okay, I guess everyone is back. So this network which was shown in this video, it is formally called a citation network. I hope all of you are aware what paper and references are. Right, and I thought that otherwise video would have made it clear. So just a second, I'll share my screen. Yeah. Uh, this is yet another network which is now completely different from the research and papers. This network is between countries. So a journalist has made this network based on the weapons exchange between the countries, and they are trying to predict here which countries will be together in Third World War if it happens. Right. So as you can see here, there are roughly three groups which they made here. The one is the yellow one, blue one, and red one. Again, based on the weapons exchange between these countries, and then based on this network, they also tried to figure out which will be the most influential countries in the Third World War. Although this figure is sort of contradicting the basic idea which we discussed yesterday, that when a world war happens, majorly there are two groups and not three. So with time, as you see, these two groups, they will merge with each other, and probably there will be two groups left at the end. There are these some other interesting networks. So this network, it is now based on Wikipedia. So there are people who are editing these Wikipedia articles which we discussed yesterday. So if two people, they edit the same article, we connect them with a link. So it seems like those two people are having the same interest. The same idea is also used in recommendations. If I and you, we have read the same book, there is a good idea, there is a good chance that we are similar in at least our interest in the books. So this is a network between the Wikipedia authors, and then again you see some authors which are represented by bigger nodes, which are more influential. And I'm again and again using this word influential. What exactly defines influence? When do we say someone is influential? We'll again look at that as the course proceeds. This is another network. This is based on some music bands. So person who is interested in music has written a blog on it, and I'm not really aware about these bands. Maybe some of you are. So you can make a better sense of this network and look at these small clusters which are there between these bands. Here is yet another network. This is based on the 6 Star Wars movies, and this person, he has taken the pain to uh, dissect each and every movie and see how much do these characters interact with each other. So you look at how many times two characters have a dialogue with each other, and you see here some of the edges are thin and some of the edges are thick. So if two actors, they are having frequent dialogues, you will see them connected with a thicker edge. And again, based on this, you can determine who is the most central actor in these movies. So these were some networks which are slightly away from social computing, but always feel free to pick up any network which can be represented as a graph for your projects, and see if you can look at some more interesting data sets. I have shown you some here. I'll also give you a whole big various links for the databases of networks, which have a whole lot different kinds of networks. Coming back to social computing, here is a very interesting research which utilizes again the idea of social computing, uh, specifically in sociology. So as you see this network here, again it's a network between people, and again you see a link between two people if they are connected in some sense. So again they can be husband and wife, they can be father and children, mother and children, friends, siblings, and whatnot. But what this network here studies is, so you see here there are nodes in different sizes. So the most visible nodes here are those in green color and yellow color, and there are some smaller nodes which are in blue color, not even properly visible here. But the point is, if you look at this network, the size of a node in this network is their body mass index. And if you look at these nodes which are yellow in color, these are the people who have a body mass index of greater than 30, who are clinically obese. And what this scientist, so this scientist, his name is Christakis Nicholas. He's a sociologist, works in social networks, but is actually a medical doctor. So he looked at this network, and he also looked at how this network changes with time. So with time, people break friendships. With time, people make connections. With time, some people leave this network, they die. With time, some people join this network. And most importantly, with time, people change their body mass index. So here is this small animation which shows how this network changes with time. So look at this animation. I'll repeat it 2 times for you and tell me, what do you observe? Any observations?
Ma'am, the network was predominantly green at first, and then slowly it evolved to like more yellow nodes.
Nice observation. So with time, the entire network has gained weight. There are more and more overweight people in the network. Right? And there were a lot of anyone else who wants to give any other observation? So this is our last point of discussion today. Probably after this, we'll end this. We'll take the remaining points in the next session. Yes, on to you. So there were other various interesting things which were seen in this network. So one, definitely the entire network, it gains weight with time. Another thing which was seen is with time you will see that yellow nodes, they move close to each other. So mostly if you see the network after this animation has finished, at the end, at the last snapshot, if you look at this network, you will see that obese people, they are connected with each other. Why do you think that will happen? That's a very interesting sociological question. Any idea why would you see obese people friends with each other?
Ma'am, mostly thin people, I mean, not thin people, but like normal weight people, they'll tend to kind of dislike or something. They'll start disliking other obese people. So only obese people will understand what obese people are, and they'll become a closely knit community.
Yes, right. So what he's essentially saying is it's called birds of a feather flock together. We mostly like to become friends with people who are like us. So not only in the context of weight. If you talk about friendship in a classroom, so you will see that mostly good scorers are friends with good scorers. Some and backbenchers are friends with backbenchers. Similarly, people who have similar body weights, they tend to become friends with each other. That is one reason. Any other reason that you can think of? And that is all, that's another very interesting reason. So you see, with time in this network, people change their weight, right? So probably initially you would see a connection between a yellow node and a green node, and as the animation proceeds, the green node becomes yellow. So that is something interesting. So that the first thing which we say, the people who are similar, they tend to become friends. It is called homophily. People who are like each other tend to be friends with each other. The second thing here, it is social influence. So if I am, let's say, normal weight and I become friend with an obese person, with time I will start gaining weight. And again, you can think of many reasons of why that would happen. This is called social influence. Right. So again, you should see, why do you see these yellow notes coming together? Is it majorly because of homophily, or is it because of social influence? And you can ask the same question in many settings. You will see smokers to be friends with each other. And now, why is it? Do you think smoker tends to become friends with each other, or is it because if your friend starts smoking, you start smoking? You also see the same scenario in the case of altruism. You will see altruistic people to be friends with each other. And again, you can ask the same question. So these are some sociological questions which we'll also address our course of during our course. And just a second, yes. Mm, yeah. So maybe I'll stop here today. So what I have shown you are some of the scenarios which can be modeled as networks. And now I leave it to you to think about more scenarios and think about what all can be seen as networks. So another thing which you can see as network is when we were in fourth or fifth grade, we would read something like a food chain, right? So organisms which are dependent on each other for food, and now that entire food chain is actually a broad area of research which are called ecological networks, because there are so many species which are dependent on each other, and then again you can figure out which species are most important in this food chain or in this ecological network. All right, so with this I'll stop here. If you have any queries, you can stay back and discuss, otherwise I'm free to leave the session.